So recording is on now. Thanks for reminding me. Okay, so we are discussing about AI. What is AI? So artificial intelligence or AI is a branch of computer science. So this is a branch of computer science that aims to create systems capable of performing tasks that typically require human intelligence, such as reasoning, learning, problem solving, and understanding. So AI is basically in one line, if I would say, so AI is simulation of human intelligence in machine. So it's like machine showing intelligence similar to human intelligence. So that is something we refer as AI. So talking about the core abilities of AI, so AI system can basically, can learn. So they are designed to learn. That means they improve through experience. They can reason. That means they can make logical decisions. They can perceive. So perceive means when we are talking about perceiving anything, so we are talking about different senses, right? So different human senses like, see, hear, understand, vision, and speech. So everything what a human have, the senses that human can perceive, same thing, the AI systems can also do. And fourth core ability is act. So they can perform actions in the real world. So if we take the example of robots, self-driving car, so these are some of the AI systems which can, perform actions in the real time, right? In the real world. They can basically, if we'll talk about self-driving car, so they can basically drive on their own. They can stop, they can start on signal. So anything which human is capable of, same thing AI can also do that particular things. Yeah. So this is about the definition of AI or introduction about artificial intelligence. Next thing, types of AI. So we have three types of AI. Narrow AI, which we call as weak AI. Then second type is general AI, which we call as a strong AI. And third one is super intelligent AI. So these are the three types of AI. Let's see these one by one. So when we talk about narrow AI, so narrow AI is also known as weak AI. And narrow AI is AI that is designed to perform one specific task or limited set of tasks extremely well. And it cannot understand or learn beyond its programmed domain. And talking about the key characteristics, so it's a specialized AI, means it is built for a specific reason and it shows high accuracy in its domain, and it cannot generalize to task outside training. So whatever this narrow AI or weak AI is trained on, it will perform the task within its domain and not outside its training domain. And there is no self-awareness or human-like understanding in this. And almost every AI that exists today is narrow AI. So if we'll talk about some of the examples of narrow AI, so voice assistant like Siri and Alexa. So these are the example of narrow AI. Image recognition, where face unlocks on your phone. Then recommendation systems on YouTube, Netflix, navigation and maps, chatbots. So these all are example of narrow AI. And everything in AI world that exists as of today is falling under narrow AI or weak AI. Now let's see next type of AI. So next type of AI is journal AI or super AI. So journal AI is a theoretical concept and it refers to AI system that has human level intelligence. So with respect to intelligence, it basically exhibits human level intelligence. It has the ability to understand, learn, reason, plan, and it has multi-domain knowledge. It has common sense and it has consciousness like behavior. I mean, it's all in theory as of now, but soon it is possible after a few years that we will be able to see journal AI or super AI systems as well. and it has the ability to perform any task a human can do. Now, when we talk about the key characteristics, so first one is human level intelligence. So it can think, understand, and reason like a human. Problem solving, capabilities. So it can perform any intellectual task, not just one. It has common sense understanding. So it knows real world logic, context, and cause effect. And it exhibits continuous learning characteristic, means it learns from experience across different domains, and it has autonomous decision making capabilities, so it can plan, adapt, and make its own decisions. So examples of journal AI as depicted in Hollywood movies. So Jarvis from Iron Man, so it's an example of super AI. Ava from Ex Machina is another example of super AI. Samantha from the movie Her is also an example of super AI. And TARS. So you might have seen Interstellar, right? So TARS shown there is an example of super AI. So general AI or super AI is right now is a theoretical concept, but I am sure in coming future this will for sure going to exist in real world also. Okay, third type of AI. So third type of AI is super intelligent AI. So super intelligent AI is also a theoretical concept. It is one level above general AI, and it is also known as artificial super intelligence. So we have term AI, right? Artificial intelligence, and this is artificial super intelligence or ASI. So ASI is an AI system that becomes vastly more intelligent than the smartest human in every domain. So, I mean, it is more intelligent than smartest human ever existed in any domain. So, it is, I mean, when I'm talking about every domain, so it's with respect to reasoning, creativity, science, strategic thinking, emotional intelligence, problem solving, and decision making. So, it is beyond human level intelligence, not equal to it, but far above it. Now, when we talk about key characteristics, so first key characteristic is intelligence beyond humans. So it can outperform the best human minds in every domain. So when we talk about domain, so it can be science, creativity, strategy, mathematics, emotions, and planning. Then it exhibits exponential learning and self-improvement. So it improves itself rapidly without human help, potentially becoming billion of times smarter in a shorter period of time. And it basically it perfects it show perfection in rationality and prediction. So it understands outcome with extremely high accuracy and predicts human behavior, global patterns, and complex systems. It can create its own goal and strategies. That means it can generate new objectives, optimize them, and pursue them independently, even in ways human may not anticipate. And it has the ability to influence or control systems. It can manipulate large scale systems, digital, economic, military, or social, due to its super strategic intelligence. Again, this is, I mean, right now, this is a theoretical concept, but I'm sure this is going to exist in a few decades for sure. And if we'll talk about the examples as depicted in the movies, so the architect, so you might have seen the movie Matrix, right? So the architect shown in that movie is an example of super intelligent AI. Then Skynet. In Terminator series, we have seen Skynet, right? So Skynet is also an example of super intelligent AI. And Ultron shown in the movie Avengers Age of Ultron is perfect example of super intelligent AI. So these are the types of AI. Uh, uh, Basically, only one of its type is practically possible as of today, and rest other two types are theoretical concept for now. Now let's talk about machine learning. So what is machine learning? So machine learning is a subset of AI that enables system to learn from experience without being explicitly programmed. So when I talk, when I emphasize on the word learn, so learn means train, right? So training on something. So we say, right, the ML models are getting trained. So getting trained means they are learning. From experience means uh, for them the experience is the data set or the data that you are providing to them, and this happens continuously, without being explicitly programmed. You just do some initial setup, you provide them the data set, and the algorithm will basically run in the background, and they will eventually train on the data set provided to them. Okay. ML algo, machine learning algo uses data to identify patterns and make decisions. So one of the important tasks is basically to identify patterns and make decisions. And ML teaches a computer to learn patterns and make decision on its own. So, I mean, the whole idea of training ML system is basically for them to learn patterns and make decisions on its own. So when we are talking about on its own, that's where the machine learning comes into the picture, because machine is learning here. Second term is deep learning. So deep learning is a subset of machine learning that uses artificial neural network with many layers to model complex pattern in the data. So there is a concept of artificial neural networks in artificial intelligence, and deep learning basically uses artificial neural networks with many layers to learn the complex pattern in the data. Deep learning is especially powerful for tasks like image and speech recognition. And compared to machine learning, deep learning needs larger set of data for training, because it has to learn, it has to find pattern in a very complex kind of data. So we need to provide larger set of data for its training, and it takes sometimes quite a few months in order to learn from the data set. So this is about deep learning. Next term is Gen AI or generative AI. So generative AI is a subset of deep learning that creates new content such as text, image, music, video, or code. So when we were talking about machine learning and deep learning, till there, the main intention is to find patterns and predict couple of things like labels and predict class. So it was all about prediction, right? But when we entered into the era of generative AI, it is all about learning and then creation or generation. So when I'm talking about creation or generation, it is the generation of new content. That content basically that it generate do not exist anywhere. It basically creates a new content, and then it basically shows that content to you. So the best quality of Gen AI system is that it basically generates new content which do not exist yet. Okay, now talking about Gen AI models. So Gen AI models learn from large data set and use complex neural networks to generate original output based on patterns they discover. So they discover the pattern. Basically, what happens? You will give some prompt to that. Gen AI system prompt basically refers to the input. So that input will be the ask from the user, whatever user wants the Gen AI systems to do. Based on that particular text, it will based. It is basically trained on the wordly data. So whatever data is available on internet and different blogs, it has already basically it got trained on that data. So Chat GPT, Claude, these are the Gen AI models. Before the launch of these Gen AI models, so these companies, OpenAI, Anthropic, they have trained these models on wordly data, and it might have took couple of years to completely train them. And once they are trained, based on the user input or user prompt, they are generating the new content on based on the pattern that they discover on the wordly data on which they were trained. So this is about Gen AI. Okay, now let's talk about the human machine analogy behind AI. Okay. Okay. So when we talk about the so this side, left hand side, are the digital counterparts. Right hand side is the human counterpart. So the concept of artificial intelligence is basically inspired from what human analogy. So it is being inspired from human intelligence. Machine learning basically inspired from human ability to learn from experience. Neural network basically got inspired from the concept of how brain neurons. So basically, neural networks are basically inspired from brain neurons or biological neurons that exist in human brain. Now, talking about deep learning. So deep learning is basically inspired from neuroscience. So when I'm talking about neuroscience, it is, neuroscience, the main concept of neuroscience is how the biological neuron make connection to every other biological neuron to process the information and to understand the complex thoughts. So deep learning is basically inspired from neuroscience. And generative AI, the concept of generative AI was basically inspired from human creativity or I would say human ability of content creation. So this is about human and machine analogy behind AI. So artificial intelligence is inspired from human intelligence. Machine learning is inspired from human ability to learn from experience. Neural networks are inspired from brain neurons or how the biological neural network exists in brain. Deep learning is inspired from the science that is known as neuroscience. And generative AI is inspired from the human's ability of content creation or creating a new content. Cool. Now, when we talk about AI landscape, where all these terms fit, how they are interconnected. So you can see the outside circle is basically the artificial intelligence. So means everything, the bigger umbrella is artificial intelligence. It's a superset term. It's something which holds anything that is happening within artificial intelligence. So artificial intelligence is the superset of all, and machine learning is the subset of artificial intelligence. Deep learning is the subset of machine learning, and generative AI is the subset of deep learning. So we can say generative AI is also kind of machine learning. Yes, it is. Deep learning is also kind of machine learning. Yes, it is. Deep learning is basically an artificial intelligence. Yes, it is. So this is how the AI landscape looks when we talk about the terms AI, machine learning, deep learning, and generative AI. Cool. Now talking about the AI domains. So domain means the area of application, which all area exist where AI is applicable or where people are applying the concept of AI and leveraging this concept. So first domain is NLP, which is known as natural language processing. So natural language processing is basically divided into natural language understanding and natural language generation. So that I'll be covering separately when we'll start the generative AI sessions. Second domain is computer vision, then speech and audio processing, recommendation systems, robotics, IoT, Internet of Things, gaming, education, cybersecurity, fashion industry, software development, finance, and insurance. So these are some of the examples of AI domains, that is domain where AI exists. Okay. So this is about the introduction about AI. Any doubts before we move forward? Anything anyone wants to add?
Yeah, Abhinav. So nowadays I heard about agentic AI or AI agents. So are they part of generative AI or is it
Yes, so
a
agent,
same?
yes, so agentic AI is basically part of generative AI only,
Hmm.
and so so we cannot specifically, we don't want to specifically mention within generative AI, because it is actually agentic AI and AI agents are something which basically results in generating new content. So generative AI basically contains everything: generation of new content, as well as AI agent concept. So everything falls under generative AI. So we are not explicitly
Hmm.
separating it out from generative AI. Yeah, but it is part of generative AI itself. So it is something which is happening. I mean, latest in the generative AI field. So who knows?
Okay.
So when I was talking about super intelligent AI, right? So
Hmm.
probably from generative AI itself, there might be some new domain or some new, branch of AI that may emerge in future, which will result in super intelligent AI systems. But yeah, so agentic AI and AI agents are part of generative AI itself.
Okay. So it is also the part of weak AI or is it somewhere?
Yes, so everything, yeah,
Hmm.
everything which is right now exists is part of weak AI only. So agent, AI agent and agentic AI is something which we can say is something which we are proceeding towards super AI, but
Hmm.
very, very initial stage.
Hmm.
Because we have seen, right, in super AI, the systems can able to perform any task a human can do, and they can act anonymously, right? Anonymous decision making we have seen here. So AI agents are also something which are making autonomous,
Hmm.
decision on their
Hmm.
own. So I would say it's a start of general AI, but very, very starting phase.
Hmm.
But as of now, we are, tagging that under narrow AI only.
Hmm. Okay, got it. Thank you.
Cool. Okay. Now, what are we going to see next? Let me. Okay. Before that, okay, I will also talk about some of the algorithms, because you might have heard a lot of algorithms, right, in AI ML field, right? So let me create a mind map on that. So we are talking about AI. Okay. So AI is basically divided into machine learning, ML part, and non-ML part. Okay. Now, when we talk about non-ML part, what exactly exists under non-ML part? So non-ML part means rule-based systems. So if else is an example of rule-based system. So uh, rule-based system, if else is basically the part of AI very starting phase when the AI started developing, but it comes under non-ML part, not under machine learning. What else is there in non-ML part? Finite state machines. So finite state machines are another example of non-ML AI, and then search algorithms, search algo. So these are some of the algorithms under non-ML part, not talking about ML part. So ML is again divided into deep learning, DL, and non-DL part, right? Now, when we talk about non-DL part, what all algo exist? So linear regression, and then logistic regression, KNN, and random forest. So every algorithm that you might have heard in uh, machine learning, so they are part of machine learning, but non-deep learning part, non-DL part. Now, when we talk about DL, means deep learning. So deep learning is further subdivided into two categories, Gen AI and non-Gen AI part, right? So non-Gen AI part may, if we'll talk about the algorithms, so non-Gen AI basically contains feed-forward neural network, FNN, CNN, and RNN. Okay, so these are the algorithms that basically exist under non-Gen AI part. Now, when we talk about the model and architecture within Gen AI, so it has transformers, then GAN, VAE, and diffusion models. So this is about expanding the AI landscape. So AI landscape that we have seen now. So it's the extension to it, how different algorithm basically how many algorithms are there and under which exact category they fall. So we can say that search algorithm is a part of AI. Yes, it is part of AI. Is search algorithm part of ML? No, it is not. Linear regression, is it part of deep learning? No, it is not. Linear regression, is it part of machine learning? Yes, it is. Random forest, is it part of AI? Yes, it is. Similarly, let's talk about diffusion models. Is diffusion model part of deep learning? Yes, it is part of deep learning. Is diffusion model part of non-ML? No, it is not. Is diffusion model part of AI? Yes, it is. Is diffusion model part of machine learning? Yes, it is. So this is how the AI landscape looks. So it took me almost, when I was studying machine learning, deep learning, so it almost took me 10 to 15 days to come up with this particular explanation. It is very confusing for the starters or for anyone who is just beginning to learn ML and AI. So just remember this AI landscape and how different algorithm fits here. Okay. Now next thing that we will be going to study after the break, we will take break after this 10 minutes break. So we will start with machine learning. Okay, machine learning may we will see we will revise what is ML. We have already seen what is ML, right? Then we will see main learning paradigms in ML, and then important terminologies in ML. So important terminologies. So important. So this is very important. Important terminology. So there are many terminologies used in machine learning, right? Like sample, features, training data set, validation data set, architecture, parameter, training, blah, blah. There are a lot many. So this might be a very interesting session for you guys, important terminologies. But before that, we will basically revise what is ML and then main learning paradigms in machine learning. Okay, so for now, we'll take 10 minutes break, and then we will start on these concepts after 10 minutes. Hey everyone, welcome back. Okay, so before we move forward, any other question on AI fundamentals or AI basics? I hope the concepts are clear, right? About the basic terminologies, not terminologies, I would say, but on the basic of AI, ML, deep learning, and Gen AI, right?
Yes.
Cool. So let's move forward now. Okay. Okay, so we are talking about machine learning. What is machine learning? We have already seen, right? So machine learning is a subset of AI that enables system to learn from data without being explicitly programmed to make decision. Okay, so let's do one thing. Let's uh, make two columns. So this is machine learning and this is human learning. Okay. Now we will basically compare the terms side by side. So what happens in machine learning? It trains on data, right? And what it basically do? It makes predictions. Okay. So this is machine learning. Human learning, if we'll see in human learning, so what is the similar concept of training, that exists in human learning? It is learning, right? And human learn from what? They learn from experience, right? And after learning from experience, what they basically do? They make some decisions, right? So this is the comparison of digital as well as human counterparts side by side. So human learning from experience means, let's say if you want to learn some concept or during your school days or college days, so you are learning some new concept, right? So you basically learn from experience. So experience means you will be sitting and reading the books, and then you are experiencing some practicals or writing down the concepts to revise. So everything that you are doing in order to learn new concept basically falls under the experience. So you are learning from experience, and then finally you are giving exams on that particular topic, and based on the question, so you are making finally you are making some of the decisions based on the learning that you have done, right? So this I'm talking with respect to study, but there are many things that you learn apart from study, right? There are many things that you learn in relationship, you learn in office, right? While you are doing your official work. So there are with respect to human learning, I would say there are endless possibilities. But this is how it correlates with human learning. So machine learning, how it correlates with human learning. So this is about machine learning. Now, when we talk about main learning paradigms, first of all, uh, what is the meaning of paradigm? So paradigm means overall style or approach of learning from data. So when we talk about paradigm, so it is overall style or approach of learning from data. So there are four types of paradigms, means there are four different ways in which machine can learn from data. First one is supervised learning. Second one is unsupervised learning. Third one is semi supervised learning. And fourth one is reinforcement learning. Okay. Now, when we talk about supervised learning, So supervised means, as you can make out from the term itself, supervised means under some supervision, right? So that supervision is basically providing the model both features as and label. So here we provide both features. What are features and labels? Don't worry about it. We will, cover it up in some time. So features, comma, labels, both will be provided to the model. And then model learns to map feature to label. So feature are basically the inputs, labels are basically the outputs. So this is about supervised learning. When we talk about unsupervised learning, so in unsupervised learning, we only provide only features we provide and no labels. Okay. And yeah, and semi-supervised is basically okay. Before coming to semi-supervised, so in unsupervised learning, we only provide features and no labels, and model finds hidden patterns and groups. So clustering, and then product recommendation on your Netflix, movie recommendation on Netflix, and then product recommendation or on your Amazon application. All these are examples of unsupervised learning where you are just providing some features to the model and no output is defined there. You are not providing any output. And then model learns from the complex data and find hidden patterns and then basically recommend movies or products for you. So that falls under unsupervised learning. Now, semi-supervised learning is a mix of data. So some rows have features and labels both. Some rows have just features. So semi-supervised is basically the amalgamation of supervised as well as unsupervised learning. And the last one is reinforcement learning. So reinforcement, as the word says, reinforcement means you are reinforcing something, right? So model learns by trial and error, and model gets rewards and penalties. So example is chatbot, right? So you might have seen that chatbot, ChatGPT, or any other chatbot, GenAI chatbot have like and dislike button, correct? So when you are talking with that chatbot, you are giving some prompt, it is giving you some response. Then if you like the response, and if you like it or if you dislike it, I mean, from the buttons provided there, then in that case, model adjusts to produce more responses that leads to positive rewards and fewer negative rewards. So that means you are reinforcing the model to learn from the experience, and that reinforcement learning comes from the like and dislike that you are providing to the response that it is generating. So this is the typical example of reinforcement learning in machine learning. So these are the main learning paradigms in machine learning. So human learns from experience to make decision and apply knowledge. Machine trains from data to make prediction. That analogy we have already seen, right? Now, important thing, important terminologies. Okay, so what we will discuss, I will tell you one by one. So we will first discuss about data set elements. What is data set? What is basically data set elements, feature, non-feature, sample, metadata, input, actual output, predicted output, everything we will cover under data set elements. Then next is data set split or splits. So data is basically divided into training, validation, test data set. There are many things, and why we do that, we will also discuss on that. Then next is model components. So model components may model, architecture, parameter, hyperparameter. There are many terms we will discuss under this model components. Then next is training processes. So training processes may loss function. What is loss function? Optimizer, underfitting, overfitting. All those concept comes under training processes. And finally, evaluation and metrics. So, I mean, regression, classification, every, I mean, the regression and classification are two types under supervised learning. So, what are different, performance evaluation metrics under each of these categories? We will discuss that. Just the, we will touch the surface, and later on when we'll pick up, examples and lab sessions, so we will learn more about it then. Okay. So first of all, data set elements. So data set elements, let's discuss on what are data set elements. So let's take an example of this data set. Okay. Isko, let me color it to make it little beautiful. Okay. So this is a data set. So data set is some data, right, which you will be providing to your model, right? So any data that you will get, let's say my aim here is that I will be providing this data to my model. It will learn from this model. And then once my model is ready, I will provide some new data. Let's say I will provide new size, bedroom, and location. And then in that case, it will be able to predict the price for that house. So that is my use case, right? Training the model on the data set, model learns the pattern, and then finally it predicts the price on new data that is coming to it. Okay, so any data that is basically used for machine learning training is known as data set. So this is data set, whatever you are seeing, right? This data set can be tabular data, which you can see in this case. So this is a tabular data. So tabular data means Excel data or CSV data. Then it can be pixel data. There can be in many ways you can provide the data set. But one of the most common thing is tabular data set that you provide in machine learning. So this is a data set. And let's say this data you are generating, let's say you have a company or you have an application which basically records all the information related to real estate, selling data that is happening in particular area, right? And this data that you are extracting in the CSV file or an Excel file basically comes from, some background logic which is generating this data basically. So as this is the first level of data or first data that you are getting for machine learning, we call it as raw data set. Okay. So this is raw data set. Everything, every data that you can see here, collectively we call it as raw data set. Why it is raw? Because you can see for some of the entries we have missing value, right? यहाँ पे notes is missing, यहाँ पे size is missing, यहाँ पे bedrooms is missing, and here location is missing, price is missing. It is a raw data which is coming from some background process from your application, or some of the process, you have created some process within your application or within your company which is generating this raw data set first hand. So the first hand data set that you are getting is known as raw data set. Now, from this raw data set, what we do, we clean the data. Okay. So first step is clean the data, right? Now, cleaning the data, when we clean the data, cleaning the data basically comes as one of the step of feature engineering. Okay, what is feature engineering? So feature engineering basically comprises of steps like feature selection, cleaning the data, deciding what are feature, what are non-feature, what is label, filling, missing values, encoding the values. So everything comes under as part of feature engineering. Now from this raw data set, we have to clean the data so that what we will be getting, we will be getting clean data set. So this clean data set is something which we will use for training our model. Okay. Now, as part of cleaning, what exactly we need to do? So as part of cleaning, we will first thing that we will do is we will fill missing values, right? So numerical values, let's say some numerical values are there. So for numerical values, we will fill the missing value with average of remaining values. Okay. For categorical values means, so numerical values are simple, right? Where you are seeing numbers, size 1200, bedroom 3, price 350. These are numerical values, right? Missing numerical values. Categorical values are string values, like notes you are seeing location. So these location notes are the missing categorical values. So here are few things that you can do. First thing is add by human judgment. Okay. If you are not able to add, or if you're not able to make any judgment, then add unknown. And before adding unknown, what best thing you can do is you can add most occurred category. But if you are not able to make any decision, then you can add unknown. Okay. So these are few of the rules that you will basically apply in order to fill the missing values. Now, there is one more step which I will not discuss now, otherwise it will confuse you unnecessary. There is one more step that we take, which is known as encoding. So encoding basically happens for categorical values. Categorical values क्या क्या है यहाँ पे? We have urban, suburb, rural, urban, suburb, right? So these are the categorical values. Why we have to do encoding? Because machine only understands number, right? So we have to change this string into a set of number or set of metrics so that machine can understand when we will provide the data set to it. So as of now, I will skip this encoding. So later on when we'll be discussing the
We
example.
know why we are calling location as categorical values.
So location categorical values means string values. Numerical value means number values.
And what about nodes?
Nodes are also categorical values. So let's say, okay, let's take an example here. This nodes categorical value and location is categorical value. Rest everything can be represented by number, timestamp, size, bedroom, price. So those are number values. So that is the difference between numerical values and categorical values. Okay. So this is the step that we take. Raw data set से clean data set बनाने में. So let's make this raw data set to clean data set. Okay. So we'll fill the missing values. Okay. First missing value that we have to fill is this value, right? This particular value. So for filling missing values, we will take an average of the remaining values. So if I'll select these values, you can see average is coming as 1400 here, right? So let's add 1400 as the missing value, and let me mark it in red so that we'll be able to know, we can basically differentiate that these are something that we have added as part of feature engineering or cleaning the data set. Now bedroom, if I'll do the average of bedroom, so average is coming as 3.2. Okay, so we will fill 3 here. This is the average. Location, either location I can add unknown, or I will add the location based on the human judgment or most category appearing. So urban is appearing 2 times, rural is appearing 1 time, suburb is appearing 2 times. So either I can fill urban or suburb. So urban or suburb में से basically I have to fill one value यहाँ पे. So let's let's fill urban here. Again, it depends on the human judgment, right? You can fill suburb also. Now, last missing value is price value, right? So what we will do, we will take the average of this. Average is coming as 337. So let's add 337 here. So 337 is added here. Now, notes section is missing in this, right? So notes is something comment kind of thing, which will not contribute in model training the model. So I'll come to that later. So we will decide feature and non-feature. What are feature and non-feature? I'll come to that also.
In price or
Hmm.
the size, if we have more, uh, like in more,
If we have more values, so yeah, so you can fill average in all those values, missing values. So here we have only one missing value, right? If it, let's say we have a larger data set and 4 to 5 missing values are there, so we will, we will take out the average of all the remaining values which are present, and then whatever average is coming, we will fill everywhere where the missing values are, provided. Cool.
and the same applies with the
Same applies,
category.
yeah. For number, numerical values, same rule applies.
So this will be a manual process, or if we have a
This,
larger data set,
yeah.
then.
So if you remember, right, Raj was telling in one of the session in Panda's session that how can we add the missing value. So this
Mhm.
can be achieved using Panda libraries. You can
Okay.
feed that data to Panda, and then you can build a logic around missing values. And basically, you can build the logic programmatically to handle the missing values. So it can be
Mhm.
done programmatically.
Okay.
But as I'm explaining you different terminologies, so
Mhm.
I'm just showing you how we basically move ahead step by step.
Okay, fine.
So okay. So this is missing value, categorical value. We can add by human judgment. So let's add second entry here. This I'm adding by human judgment. I can add unknown also, or I can add the most appeared categorical value, but adding the most appeared categorical value in notes will not make sense, and I will make human judgment here. I will do human judgment here, and then I'm adding second entry. Now, whatever I basically get after uh, cleaning my data. So there is one more step, encoding step is there. I'm ignoring it for now. But yeah, whatever data that you get after cleaning your data set, so this everything is known as clean data set. So this is known as clean data set. Okay. Now let's talk about feature, non-feature, and labels. Okay. So what is feature? So feature, first of all, in layman terms, if we talk about features, features are inputs given to model. Non-features are uh, columns that we don't give as input. And label or labels, I would say label only, singular, because in most of the cases, we basically deal with only one column when we are talking about label. So label is something known as output. Okay, if you look this data closely, let's divide feature and non-features. Okay. Now, if you want to train your model so that when it learns the pattern, it is able to predict the price. Now, based on my statement, can you figure out what are features and label first of all? Can ID or serial number be feature? No,
No.
right? It doesn't. It doesn't matter. Can timestamp be the feature? No, it doesn't matter because we are doing mathematical calculation. We will do mathematical calculation in the background, and some concrete or some solid things we have to provide for it to do that mathematical calculation. Will the notes or the comments basically matters? No, right?
No.
But size bedroom, and location is something which will matter. Okay. And what we are predicting? We are predicting price, right? So size, bedroom, location are known as feature in this case. So features, if I'll talk about features, so these will be the inputs, and this will be size, comma, bedroom, comma, location. So these are the features. What is this price? This is something I have to predict, right? Output, right? So this
Yes.
is known as label. Yeah, is someone saying something?
No, that's me. Sorry.
Okay. So label is price. Now everything else, uh, these three columns. So these are known as non-features because these are not important. These will not serve any uh, uh, this will not serve any purpose when I will go ahead and train my model. These are redundant for me, right? These are insignificant for me. So this is the difference between non-features, features, and labels. Okay. So now if I further subdivide my data, so let's look at another angle. So this is known as, okay, let me divide this again. Okay.
Abhinav, if you have to predict the change in price based on the it's year on year, right? Because the prices, then timestamp will not come into play.
Yeah, in that case, it basically depends on your use case, right?
Use
Yeah,
case.
if you want to
Okay.
predict the price on, let's say, calendar year, based on your calendar year, then timestamp will become feature. But in my current use case, I just want to predict the price based on size, bedroom, and location. So in that case, we can we can ignore timestamp. So again, so that is where the feature engineering terms comes into picture. Feature engineering means you have to select your feature, non-feature, and label based on the use case that you are serving. Yeah, good point actually. Cool. So when I'm talking about this particular portion where I have highlighted size, bedroom, location, so this is known as feature data set. Price wala portion, this is known as label
Label.
data set. And this particular thing is known as non-feature data set. Okay. Now feature data set and label data set, they are collectively known as what? They are known as modeling data set. Okay. So this is what how it looks. So and uh, okay, yeah, this is okay. And we are talking about clean data set, right? So we can call feature clean feature data set, clean label data set, clean modeling data set, or just feature data set. I mean, it depends on you. So this is how you differentiate between feature, non-feature, and label, and then accordingly data sets, feature data set, label data set, and non-feature data set. Now, next thing, let's discuss about sample. So sample is basically one row in the data set. Okay. So let's take one row. Let's take this row. Okay. So this row is a sample. This is a sample. Okay. Now sample also we can divide into three parts, right? How come? So this particular part, this is known as
Non-features.
non-feature samples. Sample. And non-feature sample ko we give another term which is known as metadata. So this is metadata. Now, if we talk about this particular sample, this one, right? So this is known as feature samples, feature sample basically. Feature sample is something we call as input, right? And then this, sorry, this particular thing is known as label sample. Label sample and label sample is known as is also known as ground truth or actual output. Okay. And uh, let's see. So this is about data set. From data set I'm providing. Let's say that I have to. So once my data is once my model is trained, I have to predict on the new data, right? So the new data, let's say I'm providing as let's say 100 and then some timestamp, let's say 2025 0117, and then all good, something like this. I'm just randomly taking 1700 square feet, 3.51, and urban, and price is something that I have to predict. So let me put dash dash here. So when we talk about this, so this part will become the unseen data. It will become the unseen sample, right? Non-feature sample for the unseen data. I mean, the whole thing will be known as unseen sample. And then unseen sample can further be divided into non-feature, feature, and label. So label will not be there. It will not include the label sample because that is something we have to predict. So यहाँ पे the price that we have to predict or the final prediction that will come will be known as predicted output. So there is a difference between predicted output and actual output or ground truth. So actual output or ground truth is something which is present in your data set, and predicted output is something which you are predicting, right? The value of y that you are predicting. So this is this is the basic of feature, non-feature, label, sample, metadata, input, ground truth, actual output, predicted output. Okay.
Which one is? Acha, this one is metadata.
So non-feature sample when I'm talking sample may it includes the name of the column as well as value. So everything for non-feature comes under non-feature sample, and we call non-feature sample as metadata. Metadata is a supporting data, not the actual data, right? And feature sample is the input data. Okay. Any doubt before we move forward? Okay.
One quick question,
Yes.
Abhinav. How do we identify the underlayers and make changes to the data?
Okay. So when you're talking about underliers, so what exactly you mean?
Okay, let's say if there is a sample which is having an abnormal data, like the price is not maybe while collecting the data we got some incorrect price. Price is there, it is not an empty price. Now whatever we have seen till now, it is an empty fields that we are filling. Red color data that
So
we are
that
filling. It
price
is
is something which basically makes no sense. That's what you mean,
sense
right?
exactly. Yes.
Mm. So that okay. So that comes as part of when you are evaluating your model. So when you are evaluating, so there are two things that you can basically do. First of all, you either make a logic where for the labels you are making some rule that your based on the input your label will basically fall under some particular category, but that is something which we usually don't follow. Second thing which we basically follow is that we are basically uh, finding the performance evaluation. We do performance evaluation of the model that we basically build. So based on performance evaluation, our model will basically uh, either is a good fit, or it a underfit, or it's a overfit. So overfitting and underfitting is something where we have to revisit our data that we are providing. So when, let's say, if it is the case of overfitting, so what is overfitting and underfitting? I'll come to it later. So other people who are not aware about it, so don't worry, we will discuss it from very scratch. But let's say if we are having the case of underfitting, then in that case we will basically revisit our data set. There we may have to add more samples there, or remove irrelevant feature, or then find some of the uh, you know uh, what you say, nonsense kind of value. So in that particular step, we have to basically build some logic where we have to identify what labels or what particular feature are present in the data set, which may produce in some vague values. So that will either be the part of feature engineering, or that will basically the part of when you are doing your final evaluation. But yeah, uh, that is something which you basically decide when you are basically evaluating your model. So if it is overfit, then there are certain steps that you need to take in order to clean your data further. If it is a underfit, then again, in case of underfitting, there are some separate steps that you have to take care. But for starters, so this is something that these are some of the basic steps that basically we take in order to proceed further before we provide this data set to our model. Okay. Now, second, okay, so we have discussed about this part, right? Data set elements. Now let's talk about data set split. Okay. So what is data set split? Okay, for that analogy also, let me divide into two sections. Okay. Let's call this side, left hand side, human side, and right hand side as ML side. So human training. Okay. Let me call left hand side as ML and right hand side as human. Okay. So when we talk about data set split, so data set is splitted into three parts. First one is training data set. Second one is validation data set. And third one is test data set. What are these? So training data set. Okay. So from this particular data set, we have to uh, divides the samples into few categories. First of all, we will take this as training data set. That means this will be the data which will be shown to the model, on which it will learn the patterns, and it will basically create its formula, mathematical formula. And in this case, prices, everything will be visible to the data, right? Now, from this training data set, we can keep some data for testing purpose before we are finalizing the model. I'll come to these concepts slowly, so don't get confused as of now. So this whole thing, let's say we are calling it as training data set. So training data set is something on which machine learns from data to identify patterns. Okay. So from this training data set, we have a validation data set also. So out of this training data set, some data we will keep for validation. Okay, what is validation data set? Validation data set. So validation data set is basically testing the prediction on based on the learning done so far. So what we will do basically on training data set, model will train. Then validation data set may what it will do, it will hide the price during the process, and then it will try to predict the price. If there is too much difference between the prediction and actual and the predicted value, it will internally, adjust the weight, and it will internally adjust some of the hyperparameters. It will again train, and it will basically do the validation till the prediction will be in a certain range. So once it is satisfied, the model is satisfied during the validation phase, then we come to the next phase, which is testing phase, where testing data set is there. So the row number 6 we have kept for testing data phase, testing phase. So testing phase के लिए whatever data we are keeping, we call it as testing data set. So testing data set में what happens? It will make prediction on unseen data set, unseen samples basically. So testing data set is something which is unseen, and training, validation, testing data set ka ratio is something which we can define when we are doing coding. And based on that, let's say 80% data we want to keep for training, 10% validation, 10% testing. So accordingly, whole data will be divided. And testing data set is something on which it will make the final, prediction. And based on that prediction, we calculate the errors, and we basically evaluate the model finally. If model is underfit, if model is overfit, then we take necessary action and then do the retraining. So this is a little complex thing, but let me try to find human analogy in this, right? So training data set, let's call it as something. Let's say if a human is there, if a student is there, he is learning something, right? So training data set means he is learning from book. Let's say learning from book with MCQ, multiple choice question with MCQ with answers. Okay. So training data set is anonymous to this particular thing. I mean, it is basically similar to this, where a human is learning from book. He's learning the concept. MCQs are there. He's going through the MCQs. He knows the answer because answer is provided in the book, and he's learning from those MCQs. And he's learning from the book. So that is something known as training data set. Now coming to the validation data set. So validation data set means he is trying out his knowledge on MCQ whose answers are provided at the back of the book. So answers are not, directly visible to him, but yeah, he's trying out his knowledge, whatever he has learned. Is it enough or not? He's trying out the MCQs. He's answering the question, and then he's telling his answer to the answer provided at the back of the book. So that is something known as doing validation. Now, if let's say out of 10 questions, he is able to answer just 2 questions correct and 8 wrong, what he will do? He will again go to the training portion again, right? He will again learn the concepts. He will again try out the MCQs provided. So he will try to solidify his knowledge. Once he solidify his knowledge, he will again go to the training validation data set. He will again try out his knowledge on the unseen data or MCQ, and then he will tally. He will do it till he gets satisfactory results. Let's say now in the unseen MCQ, out of 10 questions, he is able to answer, let's say 8 to 9 questions correctly. So in that case, we can say, okay, training is done correctly and validation is also passing. Okay. Now, now coming to the test data set. So when we talk about test data set, so it is the actual test of your knowledge. So student giving exam on the exam day. So this is the test data set. So test data set में student giving exam, he will get some new set of questions which he have not seen previously, right? And he will use his knowledge to answer that question. Now, if let's say in the exam there is a passing criteria, let's say 60% is the passing criteria. So if that person gets let's say marks less than 60%, then he is failed, right? So in that case, what we will do, we will go back to the initial step. So maybe the book from which he was learning is not enough. So we may find a new book or a different book so that he can improve his training. So similarly in machine learning, what we will do, if let's say we are not clearing the passing criteria, we will go back, we will reevaluate our sample, we will reevaluate our feature, and then adjust feature. We will add some feature, we will remove some feature based on whatever the result will be, and then again by adjusting those features, those samples, we will again do the training, and this process will repeat again, right? So for human, it will be kind of a re-exam, right? But if let's say he passes the exam, he's let's say scoring more than 60%, then we can say, okay, now this student is ready. Similarly, if my machine passes after test data set, I am satisfied with the performance evaluation of my model, then I can say, okay, my model is ready now. My model is ready. What does it mean? It means that I should be able to predict on the new data set in real world. In terms of human, we can say, okay, this student has passed the computer exam of 4th year. Let's say, I'm just taking a random example of a subject. This student has passed his exam, 4th year exam, and now he is ready for taking up the he's ready to take up some job, or he's ready to take this up professionally now. So this is the machine learning and human learning analogy with respect to splitting the data: training data set, validation data set, and test data set. I hope it's clear, right?
One question. Is a validation dataset part of training dataset, or it's a
Yes,
different dataset?
it's part of training data set.
What if the model starts remembering those values?
No,
How can
so
we identify that?
when we basically divide the training data set, so it's part of the model configuration where we basically mention the percentage of training data set. I mean the percentage of training, validation, and test data set. So it will basically take care. I mean there are many other complex concepts in that. So there are many things which needs to be applied when we are dividing the validation data set. So that we will discuss when we will build deep learning models. So for machine learning models, I'll just take the example of training and test data set. So validation data set is something which we will which we will discuss when we will build deep learning models, because because once we add the validation data set, there are a lot of complexity and there are a lot of complex concept that comes into the picture. So I don't want to complicate it initially during the machine learning algorithm learning, so that we will this complexity we will gradually include in future when we will build deep learning models. But yeah, I just want to give you the overview or the highlight of what exactly training data set, validation data set, and test data set means and why it is important. Okay. And okay, now talking about the percentage, right? So journal set of rule that we follow while deciding the percentage, basically, right? So 80% and 80%, 10%, and 10%. Basically, for smaller data set, for medium data set, and for very large data set. So there are the percentage, recommended percentage of validation, training data set, validation data set, and test data set that we basically take. So it again, it varies from case to case, use case to use case, it varies. But yeah, for a smaller data set, 80%, 10%, and 10% is something that we take. And for very large data set, it is, 98% of the data we will use for training, 1% for validation, and 1% for testing. Okay, before we move forward, there is another important concept or important term, which is known as epoch. So epoch is basically, what is epoch? So epoch is basically one complete pass through of the entire training data set. So what happens is that when we are building the machine learning models, we define epoch also. So epoch, matlab, let's say this is the training data set, and model, when it is learning, it will go through this data, this data, this data, this data, and this data, and it will learn some pattern. Now, once it goes to all the training data set once, it is known as one epoch. Let's say I have mentioned that epoch to be taken care, let's say epoch value should be 3 while training the machine learning model. So in that case, it will go through this training data set 3 times. First pass, second pass, and then third pass. So epoch is something epoch is something which we call as one complete pass through of the entire training data set. Then we have something known as batch also. So batch means subset of training data set used at a time. For example, training is happening in first epoch, and batch we have provided 2. So 2 data at a time will be used for training. So first this 2 data, then this 2 data, these 2 data, and so on. So this is one batch, this is batch number 2, and so on. So training within epoch also takes place in batches instead of taking all the row at once. So these are some of the important terms under dataset split. Okay. Now next thing is model.
Abhinav, in epoch you said the same number of rows will be trained 3 times.
Yes.
So question is why 3 times?
Because see, sometimes what happens if you are learning, so it is like revision, right? So if you are learning a new topic, right? If you are learning machine learning, so you have read the complete book one time, and I have told, okay, Sunny, your epoch is 3 times. So what you will do, first time you will learn, then in second epoch you will do revision, in third epoch you will do revision. So if you are reading the book 3 times for any exam, you have higher chances of producing good result in the exam, right? So similar way, if we are training our model in epochs by defining some epoch, it means that it will be able to find some of the missing pattern that it might have missed in first epoch. So as the number of epoch increases, it will basically it may basically find some of the missing data points that it might have missed in the earlier epoch. So that is the whole point basically.
So whenever we train the data, we always go with epoch.
Yeah, so epoch is necessary. See, in very basic ML models, epoch is not required. But if let's say we have a complex data set, right? Let's say if we have a data set of let's say 1 million data. So I mean there is a lot of data that you will provide in real time, right? So in that case, you basically provide the epoch value based on the data set, the size of the data set. So one epoch will not be able to find all the hidden patterns, right? So that's where you basically define more epochs so that your model will go on the training data set again and again. It will give more chance for finding hidden patterns that might have missed in the earlier epochs. So it's kind of like, if human analogy, if you want to compare it with, it is like basically revising your whole concept again and again before you appear for the final exam. So when you do more epochs, high chances are there that your model will perform better when you will evaluate the performance evaluation metrics for that. Clear?
When should we go for batches?
So batches again, see batches also, the thing is that let's say you have 1 million row, right? So 1 million row may, let's say 98% of data you want to define as training data set, right? So 90% of data is similar to 1 million data only, right? So if you will not define batches, and if you will bombard everything, let's say almost 1 million rows to your model, it is possible that it may not be able to learn properly. Again, if I want to compare it with human analogy, let's say you have larger data to learn. Let's say for the exam, you have 10 books, right? You have to study 10 different topics, 10 books basically. So if you'll take up in batches, for example, you will learn 2 books at a time, then next 2 books, next 2 books. That way you will be able to learn it, comfortably, and you'll be able to learn it more effectively. But what happens if I'll give you all the 10 books together to learn, and then you have to perform based on that? So that is where the batching, basically dividing the uh, data set into batches, come into the picture. So when we have more data set, so it is always recommended to divide the data set into batches, so that the model can comfortably learn on that data set in batches, and eventually we have more chance of producing a highly performing model.
Got it. And do we validate it for each epoch, or at the end of all the epochs? How does it work?
So we can validate after each epoch only, but each epoch also we can validate. But the good practice is to basically validate after all the epochs are basically passed through, because the main intention of doing epoch is that, so you are giving the time for your model to learn, right? And your model is learning in each epoch, right? So you don't want to disturb that while it is learning. In between, you don't want to disturb, right? You want to validate and test once it has learned all that, once it has completed all the epochs, right? Similarly, if you are learning something, so I'll not disturb you when you are learning, right? In between, I can ask you in between also. But I would, as a good teacher, what I will basically prefer is that once you complete all your epoch, once you have did complete revision from your side, that's when I will come into the picture and do the validation or testing from my side.
So, do we have any mechanism where through which we can decide which data set need how many epoch?
Do we have how many epoch? No,
Um, do we
again,
have
so
any?
yeah, so again, it depends on use cases. And again, there is no set of rules for this. But yeah, there are some standards. For example, let's say we have a small data set. So when I'm talking about a small data set, so I'm talking in terms of rows. So if we have rows less than 1,000 rows, it is known as a small data set. If we have, let's say, 1K rows, from 1K rows to so medium data set, if I'm talking, so 1K say 100K rows if we have, so we have we call it as a medium data set. And agar 100K say till 1 million rows are there, we call it as large data set. And more than 1 million rows if we have, we call it as very large data set. Okay. Now, for smaller data set, the recommended epoch is that for this, as it is a smaller data set, so again and again, you can ask your model to learn, right? So here you can keep more epochs, right? 100 say 500 epochs, right? Because it has time to go, and it can do the complete pass through again and again, because data set is less, so we can keep more epoch, right? If we have medium data set, then in medium data set or large data set, the recommended epochs is 10 to 100 times.
So these are the like
These are these
filter
are
data, not like.
yeah. So this is the data on which your model will learn. So it is a clean data set you can consider. And for very large data set, we basically go from 3 to 20 epochs, because for large data set we cannot go on more epochs, right? Similarly, I mean, if you want to understand through human analogy, so large data set means large things to study, right? So I remember during my school days, history civics is the worst subject for me with respect to learning, right? We have, let's say, 20 to 25 chapter to learn, and we have only 10 hours to do that learning. So in that case, I can say I have a very large data set to process and I don't have much time. So वहां पे epoch or revision will be less, right? You can think in that way. Similarly, let's say if you have environmental study paper, there only one chapter is coming and that chapter is 3 to 5 pages long. So that's a very small data set, and you have, let's say, 20 hours. You have, let's say, 2 to 3 days of holidays there, right? So that smaller data set, what you can do, you can again and again you can learn and again revise, because you have smaller data set and you can afford to have more epochs there. So these are some of the standard values. Again, that's not a hard and fast rule, but these are some of the standard values defined based on which you can define your epoch on the size of your data set. So this is how you basically decide your epochs. Clear? Any other doubt? I think we have already 2 minutes are left, and I wanted to cover model components, training process, evaluation, and metrics. So let me try to cover it quickly. And then what we will do in the next session, we will discuss on the foundation of supervised learning. We will see what is regression. We will see what is classification. And then we will see use cases on regression and classification. Probably first regression we will see. And then we will, do the Python coding for the basic flow of some of the usual, linear regression algorithms or linear regression use cases. So model component, when I talk, so there are terms, right? Model and architecture. So model, basically, whenever we are talking about model, it's a math formula we can think, right? Mathematical expression or mathematical function that maps feature and predicted output. So final trained mathematical function is known as model. Architecture means the algorithm or the type of algorithm which it follows within the background. It basically is known as architecture. Parameter is another term. So parameter is basically the numbers that model learns during the training. So we call it as intercept, coefficients, weights. So weights is something which is mostly used. Then activation functions and embeddings are something. So activation function we will learn when we will be starting deep learning. Embedding is something which is known as encoding, right? So I have told you that यहाँ पे this location is categorical value and we have to convert that into the into number value. So how we will do basically is we will assign one number. Basically three values are there. So how do we basically convert that into the categorical value? So into the number value. So urban को we will define with 1 and rest other 0 and 0. So this is the vector for urban. Suburb के लिए the vector will be 0, 1, 0, and rural के लिए the vector will be 0, 0, and 1, something like this. So when we do this kind of encoding, so this is known as one hot encoding, and one hot encoding is an example of embeddings. So these are the terms related to model components. And then training process. So next thing is training process, right? So training process may, this one. So training is basically, so we have already seen, right? Training. So model learns from data. Model looks at the data again and again to find patterns between feature and label so that it can formulate the final mathematical function which can use to predict new values. Algorithm is basically the steps that that the model trains, or the method. So some of the example are OLS, gradient descent. So these are some of the steps that it basically takes to learn from the data. Then loss function, optimizer, regularization. So these are something which is basically used in deep learning. So don't worry about it. We will learn when we will start learning about deep learning. Then overfitting and underfitting, in one word, if I want to explain. So overfitting means model memorizes the training but fails on the new one. Underfitting means model is too simple and predicts average. So when we will build the model, so then we will discuss about overfitting and underfitting, and then we will compare it with the real world, human analogy also, what overfitting and underfitting means. Then evaluation metrics. So when we talk about evaluation, so for regression, we have R square, MSE, MAE. And for classification problems, we have confusion matrix, precision recall, F1, ROC, AUC. So this again, don't worry about it. So we will gradually learn about these terms when we will pick up regression and classification problems. Okay. Just revise whatever I am teaching you in each of these lectures, because building your basic is must. So if you build your basics in a solid manner, you will be able to grasp the upcoming concepts when we will do the hands-on session in Python. Okay. Any last minute thoughts? Any last minute suggestion? Any last minute feedback before we wrap up this session? I think a lot of information in today's class. I hope 80% of the things are clear to you. So your training data set is good. Validation, I'm doing validation on you. So tell me, how's today's lecture? Did you learn something new, or did you know all these things beforehand? Whoever is, learning machine learning on their own. How's the pace of the lecture? Is it fine? Is it fast? Is it slow, or is it good? I just want to understand so that I can adjust my lectures accordingly.
The lecture was good. Learn new concepts. The pace was all right. Thanks, Abhinav.
Cool then. Thank you, everyone. So we will meet tomorrow and we will start with foundation of supervised learning. Thank you, everyone. Have a nice day ahead. Thank you.